Hello，大家，这次视频在开始之前，我先分享一个我的一个实验室同学，他 PhD，他说已经有5个月没有自己写代码了。那么我们在学习这个 computer vision 的底层代码，它的底层逻辑到底是还有什么用呢？现在连 CS 的 PhD 都不写代码了。其实它是这样的，有2个原因。第一个是，当你让你的 agent、你的特工去写代码的时候，当里面出现一些东西不工作了，这个时候你有没有这个能力去修复它？当 chatbot 没有办法去修复它自己的时候，这就是我们当前的人工智能它的局限性，它的边界在什么地方？你是否能够去，当它达到它的 limit，达到它的局限性的时候，你能不能够去修复它、发现它，以及去改进它？第二个点就是他在说，虽然他5个月没有写代码，但是他在写 prompt 的时候是做了很多工作的。他会去设计整个代码的架构，他会要求说：“嘿，你在卷积神经网络这一块，你去参考这个人的代码，他写了一个这个 pointer，去参考这个网站这个人的 GitHub 的代码。”来完成这个模块。然后下一个，比如说你求梯度下降的时候，你去参考这个人的代码，或者是参考我之前写的这一块代码，他会把一个个指针这样写好，所以就给了他的特工一个全局的一个布置，相当于说，我们现在的人工智能就是你现在我们比如说要建一个房子。我们作为人类，已经成了一个建筑师，而底层的泥水匠、底层的灰，就都会让 chatbot 去完成了。这是我对这个问题的2个理解。回到这次视频，这次视频是用 PyTorch 实现卷积神经网络。我们之前就是纯手动，把反向传播都是用手动算出来，把它的求导4层 for loop 都算出来了。但是我们现在有更好的工具，更好的人机交互界面，这个视频就会讲到。那么我们就开始吧，Let's get started. This is for the assignment 2, question 4, to use the PyTorch realize the convolutional neural network. I had a global view of the 3 mode of the PyTorch. Previously, we read the backward using this for loop. That's very messy and takes a lot of time. However, with the current API, the interface, we can have a higher convenience for the use to realize the convolutional neural network. Let's dive into that. This is the environment setup, and we introduce the PyTorch. We can read through that. Why do we use that? And oh, here we start to use the GPU. If you have GPU in your computer, you can follow this setup and enable it. That's the flexibility and the convenience comparison for the 3 mode, the abstraction level 1 to 3. We'll cover that in this video. GPU. You see here, after this implementation, I have called the CUDA, the GPU, to run the calculation. Preparation, that's the same with the previous assignment. Barebone. Here, it only use this sentence, X requires grad, then it will check the gradient at the back end. So we only need to write the forward pass. Here I raised the question if the question is what if this the function is not differentiable? For example, y equals to x absolute x, y equals to max x. The answer is that first it will use subgradient. For example, if x equals to this, the gradient will be 1. If minus this, it will be 0. So there is a very small probability to locate at exactly x equals to 0.0000. So we can ignore that case. The second one is, for example, when we calculate the max x, it will use it will save the index that which it will save the index of the maximum value in this matrix and do what we have done in the previous assignment, like we used the handwrite backward derivative and find the index of the value, do the for loop. So that's the answer to that question. And it starts to flatten the x, and this gives the example of how the data look like. Two row, one column. You see, two row, one, two. One column is only this one column. And within each meta matrix, the small matrix has 3 rows, two columns. Backbone 2-layer. First, it gives us the example of 2 layers neural networks. Then we need to implement the 3-layer convolutional neural network. Note that, bear in mind that we are in the mode 1, the most flexible mode of using PyTorch. Starts to write this part to do out. Here is the API. We call this comp2D, and the format of the comp2D is hidden information here. It's the first parameter in channels, second parameter out channels. In channels is the image we got here, and out channels is the shape of the W1 for convolutional neural network. Then we do a ReLU, and the second layer of the convolutional neural network. We get the input here, that's the in channel, and output channel is here. We use a ReLU and flatten. Finally, we use linear layer, get the score. That's the three-layer convolutional. The shape of this comp W1, we can look at the note. Here, I ask this question, why comp W1 is this shape? It is because if we look at slide 5 as 61, that's this slide. For example, the input message, input image 2 times 3 times 32, 32. That's here. Then our filter is 6355. That's here. We copy. Then the channel 1 will be this one. How many filters do we have? We have 6 filters in this picture. And the 3 is the channel in. That's the input image. Each image has 3 channels. And KW1 is phi and phi, which is the size of the filter. I mark the importance mark here. This means this one is important. 6 filters. And output of convolutional 1 will be 2, 6, 20, 2, 6, 32, 32. The 6 is from here. You see, the previous channel 1 becomes the input to the next convolutional layer, and the number of image will keep the same, 2. With that in mind, we will know what is the shape of this comp W1. It is here. Comp W2 is here. Channel 2, channel 1, this. And what is the shape of X and FCW? That's the question in the assignment. Somewhere they ask us what will be the shape of these two. The answer is see here, FCW is channel 2 times H2 times W2. H2W2 is this KH2, KW2. And the score is N times C. X after the flatten is N channel 2 times H2W2. Then after defining the forward pass, this is the forward pass. You see, we build the layer of the sequence. Run the following cell. Okay, we run this cell, we get this number, this correct shape of the score. See our channel, in channel. Here is what we say KH2, KW2. And this 3 times together. 9 is the out channel here. 32 because it kept the 30 because we have set up the pet and stride to conserve the original shape of the image. So it will still be 32 times 32. So it's here. H2, W2 will be this. FCB is 10. That's here 10. 10 labels. Backbone initialization. That's the initialization method defined by Chi-mean normalization. Zero weight. This check the function to check accuracy. Chaining loop. We call this model Fn, and cross entropy will give us the loss, softmax loss backward. That's the API to let the PyTorch do the backward and gradient calculation. And then you see we get the grad and we use the code by ourselves to update the weight. That's the core difference between this part and the mode 2 of PyTorch. After that, we run this chain part 2, we'll get 45% accuracy. Then we chain the convolutional layer and we use these parameters. This has to written by ourselves. Why it is 32355. 32 is the 32 filters. 3 is in the previous information, the input, the channel of the image is 3 channels. 5 times 5. 5 is the shape of the filter. 32, that's the filter number. 16, here the 32 channel 1 will be copied to here because the equation here, we follow this equation to write the code. 16 is the channel 2 numbers. Weight FCW is because it's zero padding, the image size stays 32 times 32. So 32 times 32. And 16 is the channel 2 number. And the class number 10. Then we call this to chain. We got 46%. Say it only need to be above 42. So we are good at here. So far we have implemented this part. The mode 1, you see we use the manual update of the weight and we write the architecture in this way. And we need to fill in the dimensions of the initialization of the convolutional W1, B1, W2, B2. Also the forward layer. We see we have a lot flexibility, but it is less convenient. Now we'll look at mode 2. Mode 2, it allows us to use the OPTM function. That's the optimization module. Also allows us to use the neural network dot module, this function. So it will do the initialization for us. Two layer. That's that's the same with the previous one. Just give us the class and how they do the initialization. We follow this format and implement the three-layer ConvNet. It's in this way. Channel one in channel is the image channel, input image channel. The channel one is the first layer, uh, the channel of the filters. Then the second layer, this is copied to here, and this is the out channel. I believe it is channel one filters. Okay, channel two filters. Two. But don't mimic cell 13. Don't mimic cell 13 and write W1 random different position parameter method. I think that's the mistake I have made when I implement this part. Then linear channel 2 times 32, 32. That's when we conserve the original image size and initialization. Forward, this part we use the same format as before, other except that we do not need to write it's here. We don't need to write the conv b1 and the padding these things in this interface mode 2. That's the forward function. We don't need to write that because we write it in the class here, where we use this NN that module. Then this is the test function. Check accuracy, chaining loop. We don't need to implement that. It's already given. Just look through that, the softmax. If we use SVM, we'll write it in this way. You will see this open optimizer step, which means we don't need to update the W by ourselves. Chain two layer. That's the example of how they chain it. That's the uh, optim.sgd, statistic gradient descent. For 44 accuracy. Here is the to do. We just copied the format like 4 and in channel 3, channel 1, it's here, 32, channel 2, 16. So in this way, we use this class to pass the architecture and the parameter of the architecture to the neural network. Use the NN that module. I've got the model. We use the optimization method to tell how do we optimize it and name it optimizer. Then we can chain it. Got 47% accuracy. See, the number is keep going up. That concludes the mode 2. If we do a comparison, we see that this part is packaged into a class here. And this initialization is abstracted to this line, only the super initial. So we write less and less code. And the weight update has become a single line here, optimizer step. It will do the weight update for us. The third mode is the sequential. We see as the technology advances, people need to do less and less math. We just design the architecture and it will do the dirty job for us. The same for us in current time and age. We only write prompts and write the good prompts, like I said in the beginning of this video. We design the pointers, we design the architecture, use human language instead of now here in the using the programming language. Let's go back to the main topic. PyTorch sequential API. This part introduced the PyTorch module API, which allows you to define arbitrary learnable layers. You see, this is the sequential. It's already given, so we don't need to write this part. We just need to learn how we use the interface. The vanilla mode, we get 42% accuracy. The three-layer convolutional, this part has to be written by the student. We just follow the format of the forward neural network, the fully connected neural network. We write the sequential, but we don't need to flatten it at the beginning. We only flatten it before the fully connected layer. Instead, we use the CompNet in the first layer, then ReLU, CompNet2 ReLU, then flatten, fully connected. That's the format here. We only need to type in the parameter and know the interface, how we pass the parameter in a correct sequence. That's it. Here is pretty very less I can explain. They are highly packaged. After that implementation, it gives us 58% accuracy. Now it requires us to do a playground game. We design our own parameters and to make it to somewhere 60%. Have fun and happy chaining. So this is my implementation. I fir what I've done is I first follow this description, prescription to do it. I don't understand what is the global average polling, so I did not do that. I did not look into this document. If you are interested, you can do it yourself. But I did follow the other instructions and get the result. Firstly, I got the result 64. It's not good enough. They require us to make it somewhere 70 or in the cell above, you should write an explanation what you have done. This is what I've done. I've explained that. Finally, I got 75%. This is my second version implementation. At the dropout I changed the dropout to 0.25, the probability to drop, and we add one more layer of the sandwich called the optimization. Honestly, this part um, can really optimize by the chatbot currently. Finally, we got 77. You may say that will be the end of the assignment, but we can ask some questions to enhance our understanding of this interface. The question I prepared is, here now in cell 13 or 14, the channel CombNet, this part. So should use the same pattern, hidden information in above cell. This 32 is the same image. Oh, we have explained that. And where is the two-layer net is in these two cells in channel. What's the meaning of the in channel parameter? We can ask this question. My understanding is the three. So the in channel is three. It's the image channel number, red, green, blue. Sometimes it can be six because it will count into for example, the edge features or the orientation features. So it will not only be the red, blue, green. Update node. This is three, only according to the cell this note. Okay, in the part four, the mode three, why do we get times 32 times 10 this match? Oh, my initial implementation, I got error report. That's because the linear layer, the fully connected layer, can only take flattened data. But I put the whole image to it, the 46 number of pictures. 16 is the channel 2 numbers, which means we have 16 filters in the second layer, convolutional net. 32 times 32 is the picture size. So the fully connected layer will complain if I put this to it. We need to flatten the three last dimensions. Here is the question, the three-layer one. Here is another question. How do we add the regulation L2 regulation, and how do we add the dropout layer? This information are not given directly in this assignment. We need to do the Google search. So after the search by Google or by chatbot, I found that this is inside the OPTIM function. Cell 31, let's see, cell 31. It's there. The regulation becomes the here weight decay. I use the regulation parameter as 1 times 10 to the power of -4. And we may ask why we use the weight decay instead of the regulation L2, because I wrote the results here. Sending down because they are the same thing mathematically, and it gives the proof obvious. We see the derivative of that is here, and after we do some combination, we get this line. So look closely at this part. Here is the decay, and will be a number slightly less than 1, for example, 0.999. So the weight will keep decaying. And that becomes the same effect as the L2 punishment, L2 penalty. Forces the weight to shrink by a tiny fraction. Okay, that's the question of L2 regulation and how to add the dropout layer. I have already provided it's here, right before the linear layer. That's the hidden information. We need to find it out ourselves. And another question is, where is the softmax option? It's now too packaged. Where is what do we familiar, the software option? It is inside the cross entropy. Question 4, iteration, epoch, batch size. What are the meaning of these three? You can test yourself on whether you understand these three concepts by pause the video and give it a thought. The answer is the neural network grab 64 images at a time, make prediction, calculate loss, update its weight. This this process is one iteration, also called one step. And in the Jupyter notebook, the print out message, we print every 100 iteration. So 64 images, one iteration. Then epoch, which means one complete pass through entire data set. We have 49000 images. So 49000 divided by 42, 64 will be 766 iterations. And that will become one epoch. So we have explained the iteration and epoch. Batch size is here. The 64 is the batch size. So that's the relationship between these three concepts. One bonus, one bonus information is the concept called translation equivariance. That means this is a good property in convolutional layer. That means if we have a picture of dog and the dog is at the left top corner, and in the training set we learn this pattern. Then in the next training sample, if we have a dog at the bottom, the right bottom corner. It will it will only change, will only shift the feature map by the same amount. They shift the feature map. However, if it is a linear layer, it need to relearn this dog at the bottom of the picture. So the linear layer, the fully connected layer, is not equivariance. The last question, using X this, what if it's not differentiable? We have explained that. So to sum up this assignment, we see the mode 3, we now use the sequential architecture. We don't need to write this anymore. We don't need to write the class 3-layer CombNet. We only need to write the sequential interface. And the chaining part are the same for the mode 2 and mode 3. Optimization part, almost the same, except that we don't need to pass the model equals to this class and the parameters. It all combined into this interface, the sequential. So we have a big picture of these 3 modes. And we also look at what we have done in the assignment to Q3. We handwrite the backward gradient descent, gradient calculation, the backward flow of the gradient in these four loops. That's what an advance, what an advantage of the current interface PyTorch. Okay, and that concludes this video. I hope you enjoying the learning of the PyTorch. We currently people usually don't handwrite the backward and they use the PyTorch. I guess choose in the middle in the mode 2 will give us more flexibility but a good convenience. Okay, I will see each other at the next video. Bye.